Welcome to The Explainer. Today, we're going to dig into a really common trap when it comes to building AI agents. Why grabbing the most advanced, state-of-the-art design right out of the gate is, believe it or not, often a direct path to failure. Let's get into it. So picture this. You find this incredible research paper on AI agents. It's the latest and greatest. You're thinking, perfect. I'm just going to copy this design. You spend weeks, maybe months, upgrading your system. You add all these complex layers, planning, memory, context isolation, the works. But when you're finally done, the agent is more expensive to run, it's actually less effective, and when it breaks, which it does a lot, it's a complete black box, impossible to debug. And that's the real head-scratcher, right? I mean, why would copying a perfect design lead to a total mess? Well, the answer is super counterintuitive. See, with normal software, a solid, robust architecture from the start is a great idea. But AI agents, they're non-deterministic. They're unpredictable. And when you layer elegant complexity on top of a system that's already unpredictable, you're not creating order. You're just pouring gasoline on the fire. You're adding chaos. Okay, so let's just strip all that complexity away. Let's go back to square one. The very first question you should be asking isn't, which fancy agent framework should I use? It should be, do I even need an agent in the first place? You know, for a huge number of tasks, a single, straightforward call to an AI model is all you need. Seriously. You give it a script, it spits back 10 video titles. You ask for a visual theme for a thumbnail, it gives you one. It's simple, it's direct, and it works like a charm. And I love this analogy of a rocket booster on a bicycle. It is perfect. Building this whole complex agent architecture with tools and memory and planning just to generate a list of titles, that's exactly what you're doing. It's massive overkill, it adds all this complexity you don't need, and it doesn't even make the result any better. And that lands us on our first and maybe the most important principle of all. Just start with the simplest possible thing that could work. If one API call solves the problem, you're done. Stop there. Don't add complexity just for the sake of it. All right, but what if the task is a little more complicated? Let's say you want to build a feature that automatically edits all the ums and ahs and awkward pauses out of a video. That's definitely not a single API call anymore, right? This is obviously a multi-step process. You've got to transcribe the video, then identify the filler words, then create an edit plan, and finally execute the cuts. Now, your first instinct might be to go, aha, this is where I need an agent. But hold on, this is where we have to make a really critical distinction. So here's the key difference. A workflow has fixed, predictable steps. It's like a recipe. An agent, on the other hand, is flexible and adaptive. A workflow just runs from start to finish with no user input, but an agent, that usually needs some back and forth. Our video editing task, that's a textbook workflow. It's a deterministic process with a clear beginning and end. So this leads us right to our second big rule. If the process can just run on its own without needing a conversation with the user in the middle of it, you're probably building a workflow. You should save agents for the tasks that are truly interactive. Which, of course, brings us to the million-dollar question. When do you actually truly need a conversational agent? When is it the right tool for the job?
The need for an agent really pops up when tasks get subjective. Think about adding special effects to a video. A one-click solution sounds great, but the first attempt is almost never exactly what the user wants. They're going to want to say things like, make that a bit more dynamic, or can you change the color palette to be warmer, or tweak the timing of that explosion. They need to be in the driver's seat, guiding the AI. And that's the real trap. If you try to handle all that subjectivity with a normal user interface, you end up with an absolute nightmare. For every little tweak a user might want, you have to add another button, another slider, another toggle. And before you know it, your clean, simple interface looks like the cockpit of an airplane. It's completely overwhelming. So it really boils down to two clear signals. You need an agent when the task is subjective and requires that human touch, feedback, preference, guidance. And two, you need one when the number of possible user requests is just growing so fast that you could never, ever build a button for every single one. The agent, then, becomes your universal input. Okay, so you've done the analysis, you've decided an agent is necessary. Fantastic. But this is where the real fun begins. Because building a good agent isn't about jumping straight to some perfect, final architecture. No, it's a process of evolution. It's driven by the problems you run into along the way. And this is the typical path you'll find yourself on. You start simple, you add new abilities, you hit new problems, you solve those problems, and you just repeat that cycle. Each one of these steps is a necessary reaction to a real-world limit you've just discovered.
So at first, your agent is basically just a fancy prompt, but you'll hit a wall pretty fast. You ask it to create a video effect based on, say, current TikTok trends, but it has no idea what you're talking about because it can't search the web. The prompt by itself isn't enough. So your first evolution is to add a tool, a web search function. And adding that first tool feels like magic. The agent is suddenly so much smarter. So what do? You add more. A code validator, an image generator, a file reader. But then, something really weird starts to happen. The agent's performance actually starts getting worse. It gets confused about which tool to use for what, and its accuracy just tanks. What's going on? Well, its context window is now totally cluttered with instructions for a dozen different tools. The solution to this is something called context engineering. You realize that having one single agent trying to be a creative designer and a logical coder at the exact same time is just really inefficient. The stuff a designer needs to know just pollutes the context for the coder, and the coder's tools confuse the designer. So you isolate them. You create sub-agents, and each one only sees the specific context it needs to do its one job well. But guess what? This creates a brand new challenge. Let's say the main planner agent gets a big block of code from the user. It needs to pass that code perfectly, without a single character changed, over to the coder sub-agent. How does it do that? If you have the planner try to output the entire block of code in its response, well, that's not only expensive in terms of tokens, but it's also super likely to introduce errors. And the elegant answer is a memory system. Instead of passing the data itself, the planner agent just saves the code block to a temporary file. Then it passes a reference, just the file name, to the coder subagent. The coder then reads the file directly. This is brilliant. It guarantees perfect fidelity, it saves a ton of money on token costs, and it solves the problem beautifully. And so, after you've gone through this whole journey, starting with that single API call, building up to a workflow, evolving into an agent, adding tools, then engineering the context, and finally implementing memory, only then do those super complex architectures from the research papers actually start to make sense. They really are the destination. They're the elegant final form that solves all of these problems you've run into along the way. Think of them as a graduation blueprint, not a day one construction plan. Trying to build that on day one is like trying to build the roof of a skyscraper before you've even laid the foundation. So the most important thing to take away from all this is to let the problems you actually face drive the complexity of your system. Don't start with some elegant solution and then go looking for a problem to solve with it. Build only what you need, exactly when you need it. And always be asking yourself, is the system I'm building a truly necessary solution, or is it just a beautiful, complicated machine that doesn't actually work any better?